नमामि शारदां देवी वीणा पुस्तकधारिणीं नमस्कार करस्तुम्मि प्रसन्नास्तु सततम्. So now we have seen how many theorems we have finished. That was the basic proportionality theorem, converse of basic proportionality theorem, theorem on angle bisector of a triangle, then the theorem on the intersect made by three parallel lines and its transversal. Now we are going to start. One more theorem, it is not explained in the textbook, that is a converse of angle bisector theorem of a triangle, but questions are there on this basis, so we'll start with that. Now we are going to start with the practice set 1.2. They are given. First question is given below some triangles and length of line segments. Identify in which ray PM is a bisector of QPR. Now you just see that this triangle PQR, PM is a ray and intersecting side QR at point M. The value of QM is 3.5 and MR is 1.5. So we have to identify, is it that PM is a bisector of it. So how we are going to write for this? In triangle PQR, QM upon MR. What is the value of QM upon MR? It is 3.5 upon 1.5. 3.5 upon 1.5. 3.5 upon 1.5 is equal to actually 35 upon 15. That is nothing but 5 3s are 5 7s are. The answer is 7 upon 3. So QM upon MR is equal to 7 upon 3, equation 1. And what is the value of PQ upon PR? It is already 7 upon 3, equation 2. So from equation 1 and 2, I can write ray PM is bisector of angle QPR. You are going to write the reason by theorem on angle bisector of triangle. Same way, see the question number 2. They are given the values. So again you are going to write in triangle PQR. What is the value of, again it is M over here. So what is the value of RM upon, we can write what QM upon MR. QM upon MR is nothing but what? 8 by 6, that is nothing but 4 upon 3. So QM upon MR is equal to 4 upon 3, equation 1, and PQ upon PR is equal to 10 upon 7, equation 2. So from equation 1 and 2, what I can write? QM upon MR is not equal to PQ upon PR, means ray PM is not a bisector of angle QPR. But as it is not a bisector, no need to give a reason like by the theorem of angle bisector of a triangle. No need to give it. When it is not there, then forget about it. Now third one is, again you are going to write in triangle PQR, QM upon MR is equal to 3.6 upon 4. 3.6, when point is there, what we do? We multiply by 10. So 3.6 into 10, again 4 into 10, that is 36 upon 40. So Qm upon MR will become 9 by 10. Is equation 1. And PQ upon PR is again 9 upon 10 only. So what I can write from equation 1 and 2, what I can write is Qm upon MR is equal to PQ upon PR. Therefore, ray PM is bisector of angle QPR. Now we are going to add this is there, then I can write by converse of angle bisector theorem of a triangle. I think I have made a mistake over here also. By theorem on converse of angle bisector of a triangle. There also we have to write the same reason by the theorem on converse of angle bisector theorem of a triangle. You have to write converse. It is not there, no need to give reason. It is there, means you have to write the reason by the converse of angle bisector theorem of a triangle. Copy this. See the question number 2. This is a figure given in a textbook. And what is given?
In triangle
PQR,
segment PM is 15 unit.
Is 15 units.
Segment PQ is 25 units.
Just we have written PM. Then
PQ is 25 unit.
PQ is equal to 25 units.
PR is equal to 20 unit.
R is equal to
20 units.
20 units.
NR is equal to 8 units.
And R is equal to
8 units.
8 units. I think I made a mistake here. Q is there. Here is R.
R.
That is.
R is there. Q is here.
R is over here.
Yes.
And
Q is here.
and M and N.
N is here. M is here.
Yeah, that is there. Okay. Okay. See here now. In triangle PQR, PM is equal to 15. PQ is equal to 25. PR is equal to 20. And NR is equal to 8. These values are given. And what they are asked to find out? What they are asked to find?
NM is parallel to side RQ.
Where the
NM, line
MN
is parallel to side RQ.
RQ. And for that we have to give a reasons which we are going to solve it. See, ये देखते ही मालूम पड़ रहा है कि ये वैल्यू दिया है ना PR का, मतलब you can easily find value of PN और इनका रेशियो निकालेंगे तो we can find out. इसलिए in this case we are going to make use of converse of basic proportionality theorem. But before that, we are going to solve it. Solution. Pn plus Nr is equal to PR. Reason is P, N and R are the cornea points. Yeah, we'll write Pm plus MQ is equal to PQ. P, M and Q are cornea points. So we know the value of Pm. Pm is how much? 15 plus NQ is equal to 25. So NQ is equal to 25 minus 15. Length NQ is equal to 20. This will become 10 units. Same way, I can take it as equation 1. I'll put out the value of Pn. So Pn plus Nr is equal to PR. The reason is P, N and R are cornea points. So we don't know the value of Pn. So Pn plus 8 is equal to 20. So Pn is equal to 20 minus 8. So then Pn is equal to 12 units. This will be equation number 2. Now we are going to see in triangle PQR, what is the value of Pn? Pm upon MQ is 15 upon 10 now. The value on here is 10. So 15 upon 12, that is Pm upon MQ will become 3 upon 2. This is equation number 3. And you can write from 1. Now, Pn upon Nr is actually 12 by 8. So, again, we can write from 2. Now, therefore, Pn upon Nr will become 3 upon 2 again, equation number 4. So, from equation 3 and 4, 3 and 4, we can write Pm upon MQ is equal to Pn upon Nr. Got it? Na? Pm upon MQ is equal to Pm upon Mr. We can get directly equal for that. Therefore, segment Mn is parallel to side QR by converse of basic proportionality Therefore, line Mn is parallel to side RQ. This is the final answer. Comment on this. See the question number 2 now. They have given, just read the question. Given
in triangle MNP,
in triangle MNP, in triangle MNP,
segment NQ
is
is a
a bisector of angle
N.
N. या फिर okay, next,
If Mn
length Mn is equal to
5 units
5 units,
and
length
length Pn is equal to 7 units,
Pn is equal to 7 units,
MQ is equal to
length MQ is equal to
2.5 units, Then find QP.
To find, what is that?
QP.
QP. For that, what I'm going to write is solution in triangle MNP. Segment NQ is a bisector of angle M and P. This is given. Don't write only N. When it is a bisector is given, means you are going to apply what? The theorem on. So we can write here also by theorem on angle bisector of triangle MQ upon QP is equal to MN upon PN. What is the value of MQ? MQ they have given 2.5. QP we have to find out. MN 5 and PN is 7. In such cases we are going to divide. Now I am going to cross multiply. 2.5 into 7 is equal to 5 into QP. So 35, then 5 to 7 to the 14, 14 plus 3 is 17.5 is equal to 5 into QP. So 17.5 into upon 5 is equal to QP. We can cancel with 5. 5 ones are 5, 5 threes are 15, 2 is there, 5 is there. So ultimately your answer for QP is equal to 3.5 units. Just you take care of these points and calculation. This question is fantastically easy. Comment on this. In this question number 4, they have given measures of some angles are given in a figure. So we'll take it as a given angle APQ is equal to 60 degree and angle ABC is also 60 degree. So they are asked to prove AB upon PB is equal to AQ upon QC. Now, in this case, they are not given that PQ is parallel to BC, but these angles are given as 60 and 60. So we know that these two angles are given, means they are corresponding angles, and when the corresponding angles are congruent, then two lines are parallel by corresponding angle test. So, solution, proof it is now. Proof in triangle ABC, angle APQ is equal to 60 degrees equation 1. Angle ABC is equal to 60 degrees equation 2. And both the things are given. Therefore, from 1 and 2, I can write as what angle APQ is congruent to angle ABC. If AB is a transversal, I can say that segment PQ is parallel to side BC. I can take it as 3, and we are going to write by converse of corresponding angle theorem of parallel lines. So ultimately, if it is parallel, now I go to I got in triangle ABC, segment PQ is parallel to side BC. Therefore, AP upon PB is equal to AQ upon QC. Reason for this is by basic proportionality theorem. Yeah, this is the final answer. Comment this. This is the question given. The figure given the question for question number 5. So what is given?
In trapezium ABCD,
So quadrilateral ABCD is a trapezium. We know that. What is the meaning of trapezium? Two sides are parallel, remaining two sides are not parallel. So these two sides are parallel. AB is parallel. What they are given to you?
side AB is parallel to side PQ,
Side AB is parallel to
side PQ,
side PQ
side DC,
and
side PQ is parallel to side DC.
side DC. अब ये तीनों parallel दिया है मतलब we are having only one that we have said the property of three parallel lines and transversal. Okay, just tell me what about they have they given some values?
AP equals to 15 units,
Length AP is equal to 15 units. This value is 15 units.
length PD is equals to
Length PD is equal to
12 units,
12 units. So this is 12.
length QC is equals to 14 units,
Then QC is equal to 14 units. So this is actually a 14 units. And what they are asked to find?
BQ.
They have asked the value of length BQ. It's a very simple question. The solution in trapezium ABCD, side AB is parallel to side PQ is parallel to side BC. This one is given. So we are going to apply directly the property AP upon PD is equal to PQ upon QC. Reason for it is by property of three parallel lines and transversal. So value of AP is 15, it is 12, BQ we don't know, and QC is 14. That figure values you are going to take from the whatever it is given to you. So 15 upon 12, BQ upon 14, we can cancel 3 4s are, 3 5s are. Now what I can do is 5 into 14 upon 4 is equal to BQ. So what I can do is 2 2s are, 2 7s are. Now it becomes 35 by 2 is equal to BQ. And if I cancel this, 2 1s are 2, it becomes 15, 2 7s are 14, 1 is left, so this becomes length BQ is equal to 17.5 units. This is your answer for length BQ. For question number 6, this is a figure given and they have asked that as per the information given in the figure. So, in figure, whatever they have given, we are going to write it as a given. So, in triangle MNP, ray NQ is a bisector of angle MNP. They have given value of MN is equal to 25 units, length NP is equal to 40 units, length NQ they have given 40 units, and they are asked to find length QP. So, solution. Now they have given, right, the bisector. So you're going to apply the theorem on angle bisector of a triangle. Simply, I'll get the value of QP. So in triangle MNP, ring NQ is a bisector of angle M and P. Therefore, we can write MQ upon QP is equal to MN upon NP. The reason for this is by theorem of angle bisector of a triangle. What is the value of MQ? It is 14. QP we have to find out. MN it is 25. This is 40. We are going to write V1. So 14 upon, or you can write 14 into 40 is equal to 25 into QP. Is it right? Therefore, 14 into 40 upon 25 is equal to QP. I think you can cancel with 5. 5 5s are 25. 5 8s are 40. And now 14 8s are. 14 8s are is 112 upon 5 is equal to QP. Now you can cancel this. 5 1s are 5, 5 2s are 10, 1 is left, 5 2s are 10, and 5 4s are. So the answer of QP is 22.4 units. Just copy down that. Now, question number 7, they have given in figure, segment AB is parallel to segment CD is parallel to segment EF. They have given the values and they are asked to find X. So see, when these three segments are given, these segments are parallel, means we are having one property, only that a property of three parallel lines and their transversals. So solution, segment AB is parallel to segment CD is parallel to segment EF. This one is given. So what I can do is AC upon CE. See, AC upon CE is equal to BD upon DF. The reason for this is by property of three parallel lines and transversals. So value of AC is 12 upon X, 8 upon 4. So 12 upon x. This is given in figure, na? So you can write as given. So 8 upon 4, 4 ones are, 4 twos are. So 12 is equal to 2 into x, or 12 upon 2 is equal to x. So ultimately 6 is equal to x, or x is equal to 6 units. Just complete this question. We go for the question number 8. This is the figure they have given, and they have given that in triangle LMN, ray MP is a bisector of angle LMN. Length LN is equal to 6 units. Length MN is equal to 10 units. Length EN is equal to 8 units. And what to find is length LB. So for this question again, MN is a bisector of angle LMN. So we are going to apply the property of a theorem of angle bisector of a triangle. So we can directly write solution. In triangle LMN, ray MP is bisector of angle L and N. Therefore, LT upon TN is equal to LM upon MN. That is by theorem on angle bisector of triangle. Value of LT we don't know. MN is 8. With that time it is 6 and 10. These values are given. Therefore,